Welcome to the project demonstration of solar panel parameters acquisition system along with display on LCD screen. So here we are going to monitor the solar panel parameters like voltage and current. So these are the main parameters. So for that purpose we are making use of a voltage sensor and current sensor AC712 and a voltage sensor, the potential divider circuits. So from these two sensors we are continuously monitoring the voltage and current by the PIC16F 72 microcontroller, so which we have interfaced at the A0 and A1 respectively. A0 interfaced to the voltage sensor, A1 interfaced to the current sensor. So parallelly directly the output from this one given as input to this and their input to the PIC16F 72 microcontroller. So we have programmed the controller to measure the voltage and current, and that will be continuously displayed on the 16:2 LCD screen. So here coming to the voltage sensor, so it has a potential divider ratio of 1:30. So whenever the input voltage is 30 volts, we are getting that control will get 1 volt. If we are providing the 15 volts, it will get the 0.5 volts. And in the coding, we have multiplied that with 30 as we are using the potential divider ratio of 1:30. And next on this motherboard, there are the three major components. One is the controller, which will take inputs and provide us the output, and a crystal oscillator, which will provide us the 20 megahertz clock frequency per second. So here the purpose of this oscillating frequency is, so inside the controller we have coded the system with input and output controlling purpose. So each instruction will be executed per pulse. Means per pulse the controller will execute one instruction. So we are providing 20 megahertz clock frequency per second so that controller can execute 20 mega lines per second. And the third one is the reset switch to restart the microcontroller. Press and release, the control will restart only. So it does it won't erase the code. So just only it will on from starting onwards. And the next is we are providing the power supply from this adapter. This adapter will take 230 volts AC input and provide us a 5 volts DC output, as it has the 4 stages inside that. So the regulated power supply board will be there in that. So one is a transformation to step down the 230 volts AC to 12 volts of AC, and next rectification to convert the 12 volts AC to 12 volts pulsating DC, and filter to remove the pulses, and regulator to regulate the 12 volts DC to 5 volts of DC, which is the main operating voltage of our microcontroller. So when we switch on that, a welcome message will be displayed on the LCD screen. Solar monitoring system. So as we said, reset switch. Okay. So now as of now there is no lighting on the solar panel. So low lighting, so it will provide us a low voltage. So when we place the lighting, either it is a solar lighting or any external lighting, so as we can see that the voltage is increasing and now decreasing, right? So when we place this solar panel under the sunlight, we will get the maximum voltage. So here we are using the 9 volt solar panel with of 3 watts of power, and next that will be displayed continuously on the LCD screen.